Hi there. We're going to look at double-sided equations. I suppose solving double-sided equations is the correct terminology for doing this one today. All right, so let's get going. Let's see what we've got this time around. All right, so to solve an equation with unknowns on both sides, that's what we mean by double-sided equation. So that means you've probably got an x on one side and you've probably got an x on the other side. It just makes it a little bit more complicated. But the first step, as it says on there, is you need to move all the unknowns, so that means all the x's or whatever the letter is, all onto one side. That's the first step that you need to kind of achieve. And anything that's not that variable, or not the x, or it needs to be on the other side. All right, so let's see what we've got. All right, so we've got 3x plus 4 equals x plus 16. All right, so if I'm going to try to get my x's onto one side, then hopefully you'll notice straight away that I've got an x, 3x on the left and an x on the right. Now for me, it's much easier to keep your x's positive, so take your smallest x to the other side. So my smallest x in this particular case is the x, because the other one is 3x. So I'm going to move that x to this side. All right, so I'm going to take away the x, which is what that bit is. All right, and when I move the x to the side, it becomes minus. So I am taking away an x from this side. So I'm taking away from the x from that side, which is going to give you 3x minus x plus 4 is equal to 16. So that's going to become 2x, isn't it? Because it's 3x's, take away another one, which gives you 2x plus 4 is equal to 16. All right, so that's my first step. All right, I've moved all my x's onto the left-hand side. Okay, step one, tick box, done. But now, I obviously want to do anything that's not an x onto the other side. All right, and you'll notice on this left-hand side, I've got a plus 4, and I don't want that there. I want to leave x on its own, so I'm going to take that to the right-hand side. And again, because I'm doing the inverse operation, I'm going to take away 4 to the other side. All right, it should be written over here, shouldn't it? I'm going to take away from the other side, and that's going to give you 12. All right, so now I've got this nice little situation where I've got x on the left hand side and just numbers on the right hand side, and I should be able to solve it from here. So we're going to do the inverse operation here. Because these are times together, then I need to divide that by 2. All right, so here you'll see it, so that 2 becomes underneath, so 12 divided by 2 is 6. All right, x equals 6. Now that is your answer. Now we're done, and we're happy with that kind of process. But of course, if it was me and it was my exam, I'd want to make sure that that makes sense and that's absolutely right. So there's a way of checking it, and you just put your value of x back into the original equation, effectively. So what's 3 times 6? 18. Plus 4 is 22. All right, so that's the left-hand side. And then is 6 plus 16 also 22? Well, yes, it is. So that's pretty much tick box. I'm happy with that. I reckon that's right. Okay, let's have another look at one. A little bit more awkward this time around because we've got a negative involved. But the method's the same, as long as I stick to it. So I've got a 4x on the left-hand side and a minus 2x on the right-hand side. Well, like I said in the first one, I always look at the smallest x and take it to the other side. Well, minus 2 is a lot smaller than 4. Okay, so I'm going to move the minus 2x to the left-hand side. All right, so when I move the minus 2x onto the other side, again, it's the inverse of minus 2x. So that's going to be plus 2x. That's going to go onto the left-hand side. So 4x plus 2x minus 1 equals 23. So that's all I've done. We can simplify this, can't we? So 4x plus 2x is 6x minus 1 equals 23. All right, so that's where we were last time around, something similar. But this minus 1 needs to come to this side, remember? So that minus 1 becomes a plus 1. All right, again, the inverse. Say it an awful lot. Let's come to the side. And then simplifying that gives us 6x equals 24. Well, following the same process as I did previously, we need to do 24 divided by 6, and that's going to give me my solution, which of course is 4. And let's double check, make sure we are absolutely right. So 4 times 4, because that's what x is, 4 times 4 is 16, take away 1 is 15. Is that right? No, it's not. Yeah, it is. 15. And then minus 2 times 4, that's minus 8, isn't it? Plus 23 is also 15. So 23 take away 8 is 15. So yeah, we're absolutely right. A little bit more awkward over here with negative numbers. And I thought I'd gone mad with the 16, but no, we're okay. It is 15 and 15. So that is absolutely right. Okay, so double-sided equations. All right, that's the first bit. There's one more little bit I want to kind of go through. Still double-sided equations, but of course you might have a bracket. All right, so you've got a bracket looking something like that, which makes it, again, I wouldn't say more awkward, but it's only going to take you more time because there's a step that you need to do before we start moving things left and right. All right, because we've got a bracket, which means times. So your best bet, really, if you're dealing with brackets, certainly looking like this, is I'm going to expand it first. All right, let's just get into a bunch of x's and a bunch of numbers. There's no x squared or anything complicated in there, so I'm just going to expand the double brackets. All right, so 5 times the x is 5x, 5 times the 7 is 35, and it's a plus. 3 times the x is 3x, and 3 times minus 5 is minus 15. Okay, so we've got to that stage. And then this should be very similar to what we had before. So I'm looking at the smallest value of x, that's the 3x, and that one I'm going to take to this side, right over there. And the reason I do that, I've mentioned that a couple of times, is simply because I don't want a negative x, all right? And I don't want a negative x, and if I take my smallest one to the other side, then I'm guaranteed to have a positive x, whichever side that's on, all right? So I tend to do it that way around, okay? So 5x take away 3x is going to move over there, plus 35 equals minus 15. So that's gone over there. So 5x minus 3x is 2x, and then I've got the plus 35 equals minus 15. All right. The 35, I need to move across, and it's going to become a negative. So here we need to be careful with negatives, because it's minus 15, take away another 35. All right. Temptation is to say 20 there, but of course it's not. Minus 15 minus another 35 is going to get me even lower down than a negative number line, isn't it? So that's going to take me to minus 50. Yep, minus 50 all the way down there. And now we need to divide by 2. Well, minus 50 divided by 2 is going to be minus 25. And again, that's my solution. Now, if you want to check that, by all means, you check it. But of course, you think about these numbers, they're not going to be particularly nice, are they? You've got minus 25 plus 7, which is going to be minus 18, times it by 5, which 90, I think. And then over here, let's double check that. So, no, that's going to be minus 90, isn't it? Minus 90, so it's minus 25 plus 7, so minus 18 times, so minus 90. And then I've got minus 15 minus another, sorry, minus 25 minus another 5 is minus 30 times 3, again, minus 90. So it is right. It's just a little bit more awkward, all right, because of the negative numbers, all right. So we trust in our process, we trust in our method, and we do it accurately and correctly, there's no reason to kind of question it, all right. If you do not get a nice round number at the end, people always think that you have gone wrong, okay. I'd agree with them in most cases. You're absolutely right in a lot of cases, especially in a foundation paper. The idea of you getting a horrible number at the end is unlikely. It's not impossible, but it's unlikely, and it certainly should raise questions in terms of your process. All right, so just double check if you get something which is a little bit more obscure, I would say, at the end that it's right. Okay. If you feel the need to practice, and I'm sure some of you do, then go to maths-school.co.uk, get yourself logged on there. Loads of kind of questions for you to kind of practice on. The link is at the bottom. All right, but that's it for me today. Cheers. Bye bye.